The unit circle. The unit circle is a circle of radius 1 unit which lies on the x and the y axis. So the y-axis runs through the middle straight up and down. The x-axis is across. The circle is used as a quick reference to look up exact values for sine, cosine, and tangent of common angles. So the center of the circle is centered at 0, 0, and the radius is 1. So if you go from 0, 0 straight right, you'll see that that dot would be the point 1, 0. Straight up is the point 0, 1. To the left is negative 1, 0. And down is 0, negative 1. And then in the middle are values for different angles. The values are determined by constructing 30, 60, 90 and 45, 45, 90 triangles within the circle and applying geometry rules to find the values we use for the sine and cosine. The tangent values, which are written in by hand around the circle, are found by dividing the sine and the cosine. So sine divided by cosine gives us the tangent values. Looking at the degrees displayed on the circle, notice that 0 degrees is found on the far right side, and the degrees proceed around the circle counterclockwise. Next to the degree values are the equivalent radian values. So at 150 degrees, you see the radian equivalent 5 pi over 6. Around the outside of the circle are values in parentheses. These are points on the x and y axis, and they also represent the sine and cosine values at each angle. The x value is the cosine, and the y value is the sine. So at 120 degrees, the cosine value is negative 1/2, and the sine value is square root of 3 over 2. They go in alphabetical order. The cosine is first and then the sine. So we'll use the unit circle to find some values for angles. Let's first do the sine of 150 degrees. So we find 150 degrees. The sine is the second number in the parentheses, which is 1/2. The cosine of 330 degrees. So here's 330 degrees. Cosine is the first number in parentheses, square root of 3 over 2. I got this circle from embeddedmath.com if you'd like to print out a larger one for yourself so you can see it better. The tangent at 270 degrees. Here's 270 degrees, and it says that the tangent is undefined. That's because tangent is sine divided by cosine, and the cosine at 270 degrees is 0. So because you can't divide by 0, the tangent at 270 is undefined. Same thing at 90 degrees. You would have to be dividing by 0, which you can't do, so the tangent is undefined. You can also look to the radians and get the trig values at the radians for each angle also. The sine of 4 pi over 3. Here's 4 pi over 3. Sine is the second number in parentheses, negative square root of 3 over 2. The cosine at 0. Notice there's no little degree symbol at the 0. That means 0 radians. It's in the same place, but no degree symbol means we're referring to radians. Cosine is the first number in parentheses, which is the 1. And the tangent of 3 pi over 4. 3 pi over 4 is right here, and the tangent is negative 1. And cotangent are not written on the circle, but we can find them by finding their partner values and flipping them over. And by partner, I mean that secant is the cosine flipped over, cosecant is the sine flipped over, and tangent is the cotangent flipped over. Let me jot that down. Secant is the cosine flipped, cosecant is the sine flipped, and cotangent is the tangent flipped. So if I want to find the cosecant of 210, here's 210, I need to find first the sine of 210, which is -1/2, and then flip it over to find the cosecant. So that would be -2/1, or just -2. The secant of 45 degrees. So secant goes with cosine at 45 degrees. The cosine is square root of 2/2. So to find the secant at 45, I flip that over, and it's 2 over the square root of 2. Now sometimes you're required to rationalize the denominator. You're not supposed to leave a square root in the bottom of a fraction, so if you want to do that, you would multiply the top and bottom by the square root of 2, and you would have 2 times the square root of 2 all over 2, which is just the square root of 2. The cotangent at 150 degrees. So cotangent goes with tangent. At 150 degrees, the tangent is negative square root of 3/3. So I flip that. The cotangent is going to be -3 over the square root of 3. And again, if you're required to get rid of that square root in the denominator, you'd multiply top and bottom by square root of 3. -3 square root of 3 over 3 just turns into negative square root of 3. So it depends upon your instructor if you have to do that or not. And if your instructor is me, you do not have to do that. The cotangent at 180 degrees. So at 180 degrees, cotangent goes with tangent. The tangent of 180 is 0. So if we flip that over, the cotangent would be 1 over 0. You're not allowed to divide by 0, so the cotangent would be undefined. The cotangent at 270 degrees, at 270, the tangent is undefined, which means it must have been 1 over 0. So I can flip that to get the cotangent. 0 over 1 is just 0.